Welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the equation of parallel lines. We'll focus on using the gradients to form equations. These are lesson objectives, and without much ado, let's quickly look into it. So let's start by looking at what parallel lines are. When we talk of parallel lines, we say two lines are parallel if, first of all, they never meet, no matter how far they are extended. What do we mean by they never meet, no matter how far they are extended? If I have this line and I have this other line, they don't meet. Yes, they don't. But then if I'm to extend this line and also extend this line, you realize that they are going to have a meeting point over here. You see? But on the other hand, when we talk of parallel lines, then if we are saying these two lines are parallel, then regardless of how far we extend them, they never meet. You see? So as you can see, it doesn't matter how I extend them, they are never going to meet. You see? So I keep extending and they will never meet. These are what we call parallel lines. The next thing you have to take note of is that they have the same direction. They have the same what? Direction. So these are the two properties of a parallel line. Now let's zoom in with respect to what? The Cartesian plane. So let's say we have two lines that we are assuming to be parallel. So for these two lines, that is the red and the blue, I'm going to name this my line 1. So line 1 and then a line 2. Now the key condition for these two lines to be parallel is that their gradients are supposed to be the same. So let's let the gradient of L1 be what? M1. And that of L2, that is line 2, becomes what? M2. Then we say that if the two lines are parallel, that is to say, if L1 is parallel to L2, then it implies that their gradients are also the same. This is the key condition that has to be met. So their gradient must be the same. Now, this condition here helps us in so many ways, especially to solve the equation of one of the lines if we know the gradient of the other. So with this knowledge we have gained, let's see if we will be able to determine whether or not two lines are parallel. So for our very first question we have here, it says, are the lines y equals 4x plus 7 and y equals 4x minus 2 parallel? Are they parallel? So how do we know if two lines are parallel? So from our conditions, we have realized that if we want two lines to be parallel, then their gradient must be the same. So if that is the case, using our first line, which is y equals 4x, then plus 7. If you have to compare it with the slope intercept, that is y equals mx plus c, you realize that your m, which is the coefficient of x, so let's name that m1 will be what? 4. For the second equation, which is y equals 4x minus 2, if you have to compare that as well to mx plus c, then our m, let's call that m2, would be what? 4. So we say since m1, so we can say because m1 is equal to m2, which is equal to 4, then we can conclude that what? The two lines are parallels. So you say it implies that the lines are parallel. Anytime you have two set of equations, you just go straight toward the gradient. Now, there are times where the examiner might want to test your understanding, such as in the question we are about to solve next. So looking at this, it says, is the line y equals 3x plus 5 parallel to 6x minus 2 equals 10? Now, you realize that the equations are not in what? The slope-intercept form. So for the very first one, which is y equals 3x plus 5, well, this is actually in the slope-intercept form. So we can directly say it implies that m is equal to 3. You see, that is all we need. We need a gradient. But for the second one, which is 6x minus 2y equals 10, it is not yet in that form. So we'll have to rewrite it. So making y the subject, we are going to get a negative 2y equals a 10, then minus 6x. Well, we can rewrite it as negative 6x plus a 10. Now, since it is y we want, we are going to divide each and every term by the negative 2. So we divide negative 6x as well by the negative 2 and also divide the 10 by the negative 2. Simplifying, we have the negative 2 cancelling out the negative 2 so that we have the y on its own. And then negative 6 divided by negative 2 gives us a 3. So we have a 3x. Then 10 divided by negative 2 gives us a negative 5. So this will also imply that if we are to name the first one M1, then for this, our M2 is also what? 3. You see? So we can say because M1 is equal to M2, which are all equal to 3, then it simply implies that the lines are parallel, as simple as you see. So this is the first application of the idea of parallelism. Now, for the second application, we would actually be finding the equation of a line parallel to a given line. How do we go about it? So to find the equation of a line parallel to a given line, we'll go through a simple three-step process. The first one, you'd extract the gradient. So you'd be given two equations and you need to extract the gradient from the one whose gradient is available. Now, if you extract that gradient, you keep the gradient and then use it to what? Solve for the equation of the unknown or the other line whose point, at least a point you know. So with that, you can use any of the methods, but I would advise we stick to the point slope method. So let's take an actual question so that we see how we can work with these steps. So for this first question we have here, what does it say? It says, find the equation of the line that is parallel to y equals 3x plus 1 that passes through the point 2, 10. So what does our step also say? We should extract the gradient. The equation we have is y equals 3x plus 1. Now comparing it to the point slope form, which is y equals mx plus c, then it simply implies that the gradient of this line is what? 3. Now we have extracted this gradient and we would have to keep it. You see, because if this gradient is m1, now since the two lines are parallel, we can say let the gradient of the second line be m2, or let the gradient of the line that passes through this point, which is the 210, be what? M2. So it says since they are parallel, then it simply implies that our M1 is equal to our M2, which is then equal to what? 3. So with that, you have your M2 being what? 3, with your point being what? That is 210. So using the point slope method, which is y minus y1 equals m into bracket x minus x1, where our x1, y1 refers to the point we're given. So using this, then our y minus y1, which is what, 10, is going to be equal to our m, which is 3, then into bracket x minus x1, which is what, 2. This will be the equation in the point slope form. But if you want to write it as the slope intercept, then we will have to make y the subject, so that we have y minus 10 being equal to a 3 times x, which is a 3x, then 3 times negative 2, giving us a negative 6. Making y the subject, we have 3x minus 6, then plus 10. Simplifying further, we have y equals 3x, then negative 6 plus 10, then gives us a positive 4. So this here becomes the equation of that line that is parallel to what? Y equals 3x plus 4 and passes through the point 2, 10. Let's quickly go through the steps again. The question was where to find the equation of the line that is parallel to this and it passes through this point. So the first thing we needed to do is to identify this gradient, which is 3. So as you have identified the gradient, then using the point slope, we have a point and we have a gradient. Why are we using that same gradient? Because the lines are parallel. We said for two lines to be parallel, then it simply means what? Their gradients must be the same. So we are taking the gradient of one equation to solve what? The gradient of the other. And that is all we did over here. Very, very simple. Now, this question we have here says find the equation of the line parallel to, we have 2x plus y minus 3 is equal to 0. And passing through, it passes through the point negative 1, 2. Our equation is what? 2x plus y minus 3 is equal to 0. Now, this is not written in the slope intercept form, so we can't point out the gradient straight away. We would first need to make y the subject. Making y the subject, we have our y being equal to a negative 2x then minus 3. Comparing this to y equals mx plus c, then it simply implies that the gradient m is equal to negative 2. So with that, we have, since we have been told the lines are parallel, then it simply means if this is m1, then m2, which is going to be the gradient of the new line or the other line, is also what? A negative 2. And then our x1, x1, y1 will then be what? Negative 1, 2. So we can straightforward say using the point slope method, that is y minus y1 equals m into bracket x minus x1. Substituting, we have our y minus y1. y1 then is our 2. So minus 2 equals m, which is equal to what? A negative 2, then into bracket x minus the x1, which in this case is what? A negative 1. Simplifying, we have our y minus 2 equals a negative 2. Then this gives us an x plus 1, because a negative and a negative gives us a 1. Now we would have to further simplify. We have our y minus 2, which is equal to what? A negative 2 times x. That gives us a negative 2x. Then we have a negative 2 times a positive 1, which becomes a negative 2. Our y has not been made the subject. So simplifying further to make y the subject, we have y being equal to a negative 2x minus 2. Then we have a plus 2. Y giving us a negative 2x. Then Negative 2 plus 2 gives us a 0. So we end over here. This is the equation of that line that is parallel to what? 2x plus y minus 3 is equal to 0 and passes through what? Negative 1, 2. These two questions, I think, are enough to give you the basic understanding on how to approach equations that are parallel, equations of lines that are parallel to a given line. All you need to do at each and every stage is to do what? Determine the gradient, keep the gradient, and then use that gradient with the point you have been given to determine the equation of the line. As usual, I'll leave with some exercises to test your understanding. So these are the questions we have, and it says, for each pair below, determine the equation of the line that is parallel to the given equation and passes through the provided point. So for each and every pair, you have an equation, and then you have this point. This point passes through a line. We don't know its equation, but then that equation is parallel to this given one. As we have done, you use the same gradient, and then you find the equation of this line. So we'll end this lesson here. If there's any issue of concern, you can always let me know at the comment section. You can always let me know at the comment section. If this is your first time on this channel and you think it will be of help to you as well, then you can choose to subscribe so that anytime I release a video, you'll be notified as well. In our next lesson, we'll be looking at perpendicular lines. Without much ado, stay blessed and bye for now.